Hello everyone, welcome back to my channel. Today let's go over a premium medium level question that I just solved on my own. So I'm really happy about this, and I'm very glad that I was able to come up with my own solution to this problem without any assistance. So let me show you how I did it. This is a similar question to a grind 75 house robber. It's a dynamic programming one. So basically, you want to find the minimum cost to go from the first to the last row without any adjacent cells. So for example, you know that these are size 3. So let me refresh the page. The spacebar is not working. Let's say from here, you can go here or here, right? From here, you can go here or here. From here, you can go here or here. And then you basically cache all the results. Let's say 5, 6, 7. From here, you can go here or here because you can't have adjacent for the next row. And then you just calculate it until you get to the bottom, right? Starting from the first row, because you can start here, you can start here, you can start here. Okay, so let's go ahead and define a DFS. I and j are going to start at 0, 0, and then 0, 1 and 0, 2 because you know it's of length 3. So that makes things easier. 1 and then 0, 2, and then the current cell value, the total cost is 0, right? And then let's define the recursive function I, j, and cur, do our boundary checks. In that case, we just return because we're out of bounds, right? Otherwise, as I said, if we reach the last row, if I is equal to length of costs minus 1, then let's declare this as infinity because we're trying to minimize something. Then let's say self.answer is minimum of whatever the current cost is, because we already calculated the current one and we have to add the cost of costs I and j. And then obviously this is the part where we visit I plus 1, j minus 1, and then cur. So this is down and left, down and right, and then also down and left too, because again from here you can, as long as it's not adjacent, you can visit this, right? From here you can visit this. So then DFS I plus 1, j plus 2, for here you can visit this, and then current, right? And then at the end we just return self.answer because we got the minimum sum. So let's run this. Length of costs. Okay, run this. And let's return cur at each time because we want to build up the results. And let's run this. It might be too slow, so let's get rid of the other test cases because this is basically like brute force recursion. Okay, let's get rid of this. Okay, so it works, but it's too slow. And the way to optimize this, because these recursive calls can be cached, right? The result of whatever this is can be cached and reused in future iterations down the line. So what I like to do is just add a cache decorators to automatically implement that behavior and run this and submit it. And there you go, passes all test cases. So again, I'm super glad that I was able to come up with my own solution to this problem without any help and solve it completely on my own. Even though the runtime and memory aren't great, again, I'm just proud that I was able to finally consistently solve dynamic programming questions by myself. So that's it for this video. Thank you for watching and stay tuned for more.